Assalamualaikum. So let me introduce for our project background and our objective of this project. For our project background, these milling machine are the principal machine tools that have been used for a long time in milling. It is one of the most commonly machine that we can find in engineering field and industry. This machine is commonly used to precise size and shape of the material based on customer requirement. For our objective, we have two objective here, which is the first one is to design the shaft, which is the shaft itself is the spindle of the milling machine that can support overall speed until 2800 rpm. For the second objective is to carry out torque and force that produced by the milling shaft itself. As for our literature review, we have 3 points here.
Steel and alloy steel. Okay, for our material design, we choose IC 4340. That's materials has high ultimate tensile strength and high yield strength compared to the other grade of materials. The material used for the shaft should have strong density, strong matchability, and it has a low sensitivity factor, and it should have high resistance corrosions and low cost.
Our designing part, we design our shaft based on 3 general constraints: bending deflection, torsional deflection, and shear deflection. Note that there are many more considerations can be taken, such as size and spacing of component and manufacturing consideration. We also want to make our shaft that is low cost but can withstand medium use of milling. Note that shafts are made of 3 parts, which is shaft body, bearing, and taper. All of these play its own important role in spindle shaft. There are 3 forces and 1 moment acting on it. First is the force that acting by V-belt, radial load, axial load, and torque. For simulation result, there are several results given, but we are focusing on factor of safety. We can see that our shaft is in blue color when maximum stress is applied. This shows that our shaft is safe, but the middle body have the least safety factor, which is 3. We consider it as a tolerable.
Next part is the discussion. Firstly, the critical diameter. The purpose of this is to determine the minimum diameter for our shaft to work properly without failing or break. By using the formula as shown in the slide, we get the value for the critical diameter about 16 mm. So we decide to make our shaft to be 17 mm as to avoid our shaft to failure. Next is shear stress. Shear stress is defined as a force tending to concentration of material precipitation of the object. Kalian study the stress from the use is as shown in the slide. So the value we get for our stress for the shaft is 8.838 megapascal. Next is the shaft location. It is defined as the degree to which a structural element is displaced under load. So the formula used is as shown in the slide. So the next part is the normal stress. It is to determine the accuracy of the shaft design by measuring the value of the stress created by the force. The formula is as shown in the slide. So is 4.157 megapascal. Is that our shaft can withstand high stress without breaking.
Factor of safety can be defined as a ratio that compares absolute strength to actual applied load. The value of factor safety should be more than 1. This is because the shaft may fail if less than 1. We can get the factor of safety by using the equation which is yield strength divided by maximum shear strength. There are 2 types of shaft failures in our design, which is fatigue failure and overload failure. Spindle shaft is part of the milling machine. It has undergone many calculations and analysis to ensure that the shaft is suitable to function and safe to operate. In discussion, we calculate the factor of safety and we get the value of 5, which is high as to prevent the shaft from failing.